All right, we're back. We're on page 5 of note 17. This is the final page that is strictly review, and then we will start doing some calculus, which I can't wait for because it's murder making these videos. All right, let's see. So these are going to be limacons or cardioids. Cardioids are a special case of a limacon where like the axis and the sinusoidal axis and the amplitude are equal to each other. That gives you a cardioid. And a cardioid, so these always take 2 pi. And if it's a cardioid, there's just really nothing interesting about it, and you're best off knowing the shape. So it's 1, and then you can go up to 2. It's a negative sign. It's gonna be like this. So this is your rectangular graph, which you always want to start with. Start with your rectangular graph, turn it into your polar graph. Know what it should look like, and it'll save you a lot of time. So I'm gonna make this and copy and paste it. It makes me feel like maybe I should have just put grids on the notes, but like I don't really like doing that because I don't like telling people what to do and giving you like only a certain amount of space, even though I obviously only give you a certain amount of space. I don't know. Writing notes is more stressful than you would think. You know, you start thinking about the implication. It's all about the implication. All right, when theta is 0, you're going to get 1. So this is, let us keep in mind, this is the theta axis. This is the r axis. So when theta is 0, you get 1. So I need 1, 1, 2. That's like really all I think I'm going to, nope, totally wrong. Negative 2. Okay, I think that's all I'm going to really need. When theta is 0, I get 1. When theta is pi over 2, I get 0. So it's going to go like this. And you're best off just knowing that it does that. I mean, its pattern, it always does it. By the time you get to pi, you're back at 1. And you just mirror what you did. By the time you get to 3 pi over 2, you are at 2. But on the xy plane, that's negative 2. So you're down here. And then by the time you get to 2 pi, you're back at 1. There you go. That's your cardioid. It takes 2 pi always. You don't really need to think about it. So that's good. Yeah, so it was a negative sign, so I knew it would be predominantly on the negative y-axis. Like the bigger part is going to be on the negative y-axis. So this is positive cosine. The predominant part is going to be here. It's going to look like that. So like that's what I mean when I say like you want to just know what it looks like, because you don't want to spend time thinking about these. You want to just like look at them and be like, oh, this old graph, and just go for it. 1, 2. Okay, so you start at maximum. Graph and trig functions, man. Graphing sine and cosine, key. If you can graph sine and cosine, you can do polar. No question. So we need 2, 1, 1. Hey. Oh, man. There's some, like, somehow I managed to, like, zoom in all the time. I don't actually know how. All right, when theta is 0, you're at 2. When theta is pi over 2, you're at 1. By the time you're at pi, you're at 0. So you're going to go like this, this. And then when you get to 3 pi over 2, you're back at 1. But in the xy plane, that's negative 1 on the y-axis. So 3 pi over 2, you rotate 3 pi over 2, you walk 1 this way. On the xy plane, that's just y equals negative 1. So keep in mind, you're always on the xy plane. Then by the time you get to 2 pi, you're back at 2. There you go. That's your graph. It takes 2 pi all the time. These are going well. Limacons, inner loop. All right, so positive sign, so it's going to be predominantly on the y. So it's going to go kind of like that's what I'm expecting. That's what you want to know. You want to know going in like, oh, I expect this sort of thing. And then, you know, you want to do a better job than that. But so this, here's 1, 3, negative 1. 2 pi, pi. Those, they're not going to be super important, but you should have them. Here, here, here. Important point. Ew, get out of there. There. So we're going to have an important situation here, somewhere between pi and somewhere between 2 pi. We need the zeros of this, right? So if r equals 0, that means that sine of theta is -1/2, which means that theta 7 pi over 6 or 11 pi over 6. That's where we're going to start and stop our inner loop. So we're going to start and stop our inner loop at 7 pi over 6 and 11 pi over 6. What I'm going to do, dot those in. But I'm going to dot them in like kind of tiny because they're not like huge. They're in fact not relevant until you get to 7 pi over 6 and 11 pi over 6. So here we go. So when I need to go 1, 1, 2, 3, -1. Okay, I think that's what we need. When theta is 0, we're at 1. When theta is pi over 2, we're up at 3. And so you're going to kind of go like that. By the time you get to pi, you're at 1 again. But remember, that's -1 on the x-axis because you're facing pi and going 1 in that direction. So you end up -1. Back like this. By the time I get to 7 pi over 6, so this is the key thing. 7 pi over 6. By the time I get here, I need to be at 0. So I'm going to just curl in. Then at 3 pi over 2, you get -1. So 3 pi over 2, you're facing this way, but -1 puts you up here. So we'll be up here. So I'm just going to go in along a tangent line, out along a tangent line, then finish by symmetry. There you go. So your inner loop is a big deal. This is your inner loop. It happens here. And it's when you're between 7 pi over 6 and 11 pi over 6. That's going to be huge, finding that inner loop. So a lot of questions about like find the area of the inner loop, whatever. To successfully do that, you're going to need to know when you're on the inner loop. And that's going to be basically when your graph dips below. It's like wherever the minority of your graph is, right? The majority of your graph is above. So the minority of your graph is here. That's your inner loop. Let's see if we can do this one. So 1 minus 2 cosine. So it's going to take 2 pi. These always take 2 pi. Thank goodness, right? We want that. We want easy things if we can get them. 1, 3, -1. All right, cosine starts at a minimum. So here, 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 like that, like that. Okay, here we go. I would say that a negative cosine with an inner loop is the weirdest limacon you can have. Negative cosine inner loop, weirdest limacon. The reason it's weird is because it starts in the inner loop. So I need to know when r equals 0. That means that cosine is +1/2, which means that theta is pi over 3 or 5 pi over 3. And you can kind of see them on the graph, right? You're like almost at pi over 2. Well, what famous angle is almost at pi over 2? Pi over 3. Then you're a little past 3 pi over 2. What famous angle on the unit circle is there? 5 pi over 3. So you can see them on the graph, I think. 1. So what do we need here? We need, at pi, we need to be out at 3. So that's going to be -1, -2, -3. And then at pi over 2, we're going to be at 1, -1. All right, here we go. When theta is 0, you are facing this way, but r is -1, so you're actually here. So the first point we're going to make is here. And then you're rotating this way, but you're graphing this way because r is negative. And I forgot to dot in my lines. Here, and then like here. All right, here we go. There. By the time we get to pi over 2, we're out at 1. By the time we get to pi, we're out at 3, which is -3 in the xy plane. And then by the time we get to 3 pi over 2, we're back at 1. Then we're going to go in along a tangent line and come out along a tangent line. So that inner loop here is from here to here. And then you finish at the end. It's so weird. You do half of the inner loop, then you finish. Oh my God, let's keep going. This isn't even nice. Why would anyone do, why did I do this? All right, so 3, we go up to 7 and go down to -1. Let's say 3, 7, -1, 2 pi, pi. So it's not going to be nice, and that's really unfortunate. This is one of those where I'm asking myself, have I ever actually done this problem, or have I usually just been like, yeah, so, you know, finish practicing and whatever. All right, somewhere between 0 and pi over 2, there's going to be a tangent line. So I'm just going to do it. Somewhere between 0 and pi over 2, it looks like it's closer to 0 by like a tiny bit. Let's do this. And then somewhere really close to pi, there's going to be another one. So let's do this. These should be at the same angle, so that's not great. You know what the problem is? Well, it's not a problem. Like the bajillion problems that I have is my rectangular graph is not super great. Okay, I don't know. Predominantly going to be on the negative y. So it's going to go like this. Inner loop. Stop that. It's going to go inner loop, big predominantly there, and like that. That's what I'm going to go for. So, this is at 3, I guess. And then this will be -3, and then I need to like, so this will be -3, -7. That's not -3 though. Or I mean, -3 is not relevant. -1 is relevant. There. Okay, here we go. So at 0, you're at 3. By the time you get to the inverse sine of 1/4 or whatever, no, the inverse sine of 3/4, you have to be here. Okay, and then by the time you get to pi over 2, you have to be at -1. That's going to be here. And back in. And then by the time you get to pi, you're at 3, which is -3 in the xy plane. And you go like huge out to -7. And there. That's your graph. Gross. All right, so this is, so if r equals 0, we get sine of theta is 3/4. So think about where that's the first and second quadrant. So one of those is the inverse sine of 3/4. The other one is going to be at pi minus the inverse sine of 3/4. Those could potentially be the bounds of an integral. And it would be the integral that gives you the area of the polar region, which is not the same as the area of the rectangular region, but like they're similar. They're not, the areas are not at all related to each other. This one, so 2 plus 2, so it's gonna be like here, here, here. Can you tell that I'm just tired of doing these? Here, 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 there. There you go. That's the last one. All right, I'm gonna end this video here. Be back in the next one. We're finally doing some calculus stuff. Oh my God, this has been like an hour of videos, and honestly, hopefully you're watching the better videos, the math analysis videos, the videos that go along with the math analysis videos, which are also on like extra playlist for these notes, I'm sure. Highly recommend that. Kind of highly don't recommend watching these videos that you just watched. But I will be back in page 6. That's when the real calculus starts. That's when it's going to be way more worth watching. So I will see you there.